Hi everyone, in this video I'm going to go over top 15 software or DevOps tools that I use professionally. This will help a beginner get an overall understanding of what sort of tools that can be involved for creating a software product in general. So I'm not going to give a list of all these 15 tools, but I'm going to start from the requirement and work backwards showing which tools fit those requirements. So the first thing towards building a software involves basically to write code in any programming language. So I normally use Golang for my backend stuff and React for the front end, and sometimes a little bit of Python. So when you're writing the code, you have to write it in a code editor. You need to choose the editor which is best for your selected language. So there is this editor called VS Code, which is Visual Studio Code, which is open sourced and works reasonably well for most programming languages. So that is something I use. But if you want your life to be much easier while writing code, then you may need to go for better solutions that are provided for the particular programming language. So in my case, I use Golang for writing code in Go. And Golang is a code editor developed by JetBrains, and it gives a ton of features which just makes life much easier while writing Go program. So these are the editors I use. Next is once you have written your code and it works and your application runs locally, let's say, then the next important thing is to actually save the code and ensure the safety of your code. So what do I mean by that is when you are building some application, you don't start off by creating the entire thing all at once, right? So you build something small that does a small task well and then build on top of it by adding more and more features. So in the process of adding features, it's very easy to mess something up, and you don't want something that is already working well to be messed up while trying to add something more on top of it. And this is where Git comes into picture. So it works as basically checkpoints, and each of these checkpoints you can save so that in future if something goes wrong, then you can go back to the stage where it was going fine. So this is where Git is useful, and it also has a lot of other features, but this is roughly why Git is used. Next is to actually store your code base. So to store, I use GitHub, which is the most popular code hosting platform in the world, and this helps in a lot of other things such as trying to merge different changes done by different programmers and automatically deploy your changes to the production environment as well. So now we have covered writing the code and saving the code and ensuring that we are safe. The next thing is to actually ensure that if your application runs fine on your own laptop, it should also work fine in every other environment as well, because you are not going to host it from your own computer, right? So it will be most likely hosted somewhere else, like in a server or in a cloud somewhere. So to streamline this process, you have to ensure the environment in which your application runs that is consistent, so that you can always predict the outcome irrespective of what sort of machine it runs on. And this is where something called Docker comes into picture. So it helps us containerize your application so that irrespective of which sort of machine it runs on, it will always give the same output. So using Docker, you create something called a Docker image, and that image you can run it on any machine, on any supported machine, to get consistent output of your program. Docker comes with another tool called Docker Compose. So using Docker Compose, you can run multiple Docker images together in your local environment. So for example, if you have a front end and a back end system and you want to see all of them combined in action, then you can run all these services in a Docker Compose to check if your overall application runs fine. So now that you can package your application and ensure that it will always run consistently irrespective of the machine, next step is to have some automation in place. So when machines run, they always fail at some point. No machine can run and guarantee that it will never fail. So you have to ensure that even if your machine fails, your application doesn't completely go down. So this is where an orchestrator comes into picture, and Kubernetes is the most popular orchestrator, which means it will ensure all the containers which are running your application, they're always up based on your requirements. You can set the requirements such as you need a minimum number of containers or minimum number of instances so that your application can always serve a certain number of users, and you basically can feed this information to Kubernetes and it will always ensure that this requirement is satisfied. So this is basically the work of an orchestrator. It also involves a lot of other things, but this is briefly one of the most important things that an orchestrator does. And you can use this orchestrator in two ways. You can have this orchestrator called Kubernetes on your own, or you can use a managed Kubernetes environment somewhere. And usually it is much easier to use a managed service such as Google Kubernetes Engine or Amazon's solution as well. So Google Kubernetes Engine, which is called GK, it ensures that you don't have to do the work of installing Kubernetes and ensuring that it is always up. Next comes storage. So storage solution, it's not like a one size fits it all solution. So what kind of storage you use really depends on what are your requirements. So you might be needing just a caching solution or a text-based storage where you can query, or you just have big files and you just want to dump them and you want to be able to retrieve them whenever you want, and a blob storage solution might be useful in that scenario. Or you may have data which is basically in the form of time series. So based on your requirement, you have to choose the storage. So in my case, I have the requirement of blob storage, and in that case I use Google Cloud's blob storage solution, and I also use Elasticsearch. Next comes queues. So what are queues basically? Let's say you have two services running and one service sends some tasks for the other service to do, but the sender can send lot of tasks at a time and the receiver can only do one task at a time, but it needs to finish all the tasks eventually. So in that case, a queue might be useful where you basically store these tasks. So in such a requirement, I use RabbitMQ, which basically queues all these tasks, and my other service that actually gets all these tasks one by one and then performs those tasks. So that is one example of a queue where RabbitMQ is useful. I have one more requirement where one service sends some data which is only important for a short period of time, and the other service has to fetch that data within those short period of time, and it is not so critical that even if it loses few amount of data, it is still fine. So basically the mechanism we're talking about is fire and forget. So one service can basically fire and forget about it, and the other service has to get the information as much as possible, and even if it misses out on something, then it is still fine. And as the time progresses, we just need this loop to continue as quickly as possible, even if there is some loss of data. So an example of this scenario is road traffic. So you need the traffic information to be as recent as possible, but even if you miss out once or twice, then as long as there's a constant influx of the information, it is still fine. You may be off by a minute or so, but it will still just work. So in this scenario where the fire and forget mechanism is required, I use NATS queue. So NATS is an open sourced queue. It has a very good amount of availability and large throughput and works perfectly well in this scenario. Next comes testing and deployment. So if you're building a new feature in your application, then one of the most important things to take into account is that it is not failing what already works. So this is why you write tests, and these tests need to be performed every time you need to update your application. And it is better to have these automated so that you don't have to manually do it all the time, because the more manual you have to do, the higher the chances of making a mistake. So for these kind of requirements, which involves automated testing and automated deployment, so this basically falls under continuous integration and continuous delivery as well. So for these kind of requirement, I use Circle CI, which works really well in this case, although it is a paid service, but it also has a free tier as well. Okay, now that you have built your service and you have packaged it and ensured proper orchestration is in place and you have deployed it in a cloud environment and you have automated the whole chain, then the final thing is to have some form of monitoring in place, because once your application is running on the cloud, you don't have much control over it. So the best you can do is to monitor at that stage, so that if something goes wrong, then you will be immediately notified. So for this monitoring, I use Prometheus and Grafana. So Prometheus is the monitoring tool and Grafana is the visualization tool. And based on how you have instrumented your application in the form of exporting certain amount of metrics, you will get to see those metrics on the Grafana dashboard. So an example of a metrics is the percentage of CPU utilization of a machine, or it can also be like the throughput or latency of your application. And one example can be if you are seeing from your end that the latency is increasing, then you'll have to ensure that you scale things up. Or if your service is down, then you also get notified through Grafana. There are a couple of other tools as well which can fall under monitoring. So there is one tool called Jaeger, which is basically a tracing tool. So tracing means if you have many services and there is a chain of calls, so basically your front end calls another service, which calls another service, which eventually calls the back end, then this chain of execution can be tracked using a tracing tool like Jaeger. So sometimes if you have a lot of services, it is important to pinpoint which one actually failed or which one is about to fail. And this tracing tool, Jaeger, can give you a visual representation of where exactly the chain broke or which of these services is taking too long, so that you know where exactly to start fixing things. And the other tool is called Linkerd, which is basically a service mesh, which can basically track the network calls in your application. So if there are, let's say, HTTP or gRPC calls across multiple services on your backend, then it can track those and give some information about these, so that you will very easily get an overall picture of what is going on and if the services are working as intended or not. This is like a very small use case of Linkerd. There are other use cases as well. For example, load balancing, which is very important in case of a distributed system. So that's it. These are all my top 15 tools which I use reasonably regularly. And feel free to comment what tools do you use, or if you found any of these tools interesting.